To assemble this cable duct, a combination of machines bespoke for this purpose is utilized. One machine digs a trench across the sides of the track, and it's followed by a second vehicle that transports the pieces of duct, cleans the trench and slips one piece after another, creating a tight conduct that will keep the cables protected. Once the installation of the duct is completed, it's time to elevate the catenary poles on the sides of the tracks. The mission of these poles is to hold the overhead cable lines and connect them with the high voltage cable previously installed. The poles are firmly nailed to the floor by a concrete foundation. Commonly, railroads worldwide are built over a layer of ballast, which allows elasticity and resistance to absorb the impact of the train every time it passes. This method sometimes encounters problems when dealing with sandy areas. Sand can infiltrate and accumulate and mix with the ballast, reducing its elasticity on the long term. To solve this matter, in those sections, the tracks need to be built on a concrete slab, a system known as the Reda 2000 ballastless track. The project will need to combine these two different systems, ballasted track and slab track. The first step to build the ballasted track is to guarantee enough supply of ballast. More than 4 million tons of ballast will be needed to supply the whole track. This ballast is obtained from several crusher plants that have been set up for this purpose. The largest one can produce up to 50,000 tons of ballast every month. Ballast needs to be made from a very hard rock obtained through controlled blastings. Later, large pieces of rock are transported by trucks to feed 2 consecutive crushers. And finally, the gravel is classified by its size and quality, creating the ballasts and other aggregates. The ballast then is transported and distributed on the platform using a paver, which extends a uniform bed of ballast over which the sleepers will be placed. After this first layer is